Now that we have finished the attention module, we go to the next layer inside the encoder, and it's called the feedforward neural network. In the original paper, this is also called a pointwise or position-wise neural network. Let's review it. Up to this point, all the transformations that our input has suffered have been linear. With the feedforward neural network, we apply non-linearity. This sublayer is a simple neural network with two layers and one activation function in between. Even though it is a simple neural network, its role is fundamental in the transformer. The common nonlinear functions used here are the ReLU and the YeLU. When we apply these functions to our data, we help the model learn more complex patterns and not just linear patterns. One important distinction of this layer is that it transforms each word or piece of information separately, hence the name pointwise. This makes sure that each one of the words of our input is understood more in detail. One interesting note is that the internal dimensions of the network were defined as 4 times the input. In other words, if the input sequence had a length of 512 tokens, then the layers in the feedforward network would be layer 1 would go from 512 to 2048. Then we would have the activation function, and layer 2 would be 2048 back to 512. This increase in the internal dimension creates a more complex and expressive representation of the data. And again, between these two layers, we have an activation function that introduces non-linearity, enabling the network to learn and represent more complex patterns than what just a linear transformation alone would allow. Let's see how this works. In this animation, we will see how each position of the contextual embedding or input passes through the neural network. By doing this, each one of the positions in our input, that is, each word, is being processed individually, and the model is gaining more complex understanding, making it a smarter model. So, how is this implemented in code? This is a really simple function where we define 2 linear layers and an activation function. Then, in the forward pass, we take the input to the function, pass it through the first layer, apply the activation function, and pass the result through the second layer. Both the input and the output of this function have the same shape or dimension.